So let's start with Summer 21, Variant 1-3. Question number 1. Compound X is an organic compound that contains 30.6% carbon, 3.8 hydrogen, 20.4 oxygen, 45.2 chlorine by mass. What is the empirical formula? So for the empirical formula, you need to list down the elements first. So you have carbon, hydrogen, oxygen, and chlorine. Write down their percentage or mass composition. So that's 30.6. This is 3.8. This is 20.4 and 45.2. Divided by the AR. This is 12, 1, 16, and 35.5. Now, when you do that, you get the smallest, you get the number of moles. So this comes out to be 2.55. So this is 2.55. This is 3.8. 20.4 divided by 16. This is 1.275. And that is 45.2 divided by 35.5. That is 1.273. So the smallest is 1.273. So you divide that on both, you divide it all by that number. So you divide these all by 1.273. And this comes out to be 1. This also roughly comes out to be 1. This is 3.8 divided by 1.273. This comes out to be 2.98. So that is 3. And 2.55 divided by 1.273 is 2. So it will be C2H3OCl. The answer therefore is A. Clear? We got the empirical formula. A sample of propane with a mass of 9.61 is completely combusted in excess oxygen under room conditions. What volume of carbon dioxide is produced? So you have propane, which is C3H8. This burns in oxygen. They are saying to give carbon dioxide and water during complete combustion. So you balance the equation. This will be 3CO2, 4 H2O, and then 3 2s are 6 and 4, 10 oxygen here. So you put a 5 here. Now let's convert this grams to moles. So you do moles is equals to mass upon molar mass. So moles is equals to mass, which is 9.61 upon molar mass of C3H8. That's 12 times 3 plus 8. So 12 times 3 plus 8, that's your denominator, 44. So 9.61 divided by 44, and your moles come out to be 0.2184 moles. So this is 0.2184 moles. As you can see right here, the ratio of propane to carbon dioxide is 1:3. So if the moles are 0.2184, the moles of carbon dioxide would be X. You find the moles of carbon dioxide, which come out to be 0.655 moles of carbon dioxide. Now you need to find the volume, so you multiply it by 24. So you multiply by the molar gas volume, and this comes out to be 15.7 dm³. The answer therefore is D. Clear? Question number 3. Which atom has the same number of electrons as an ammonium ion? Ammonium ion is what? NH4 plus. Yeah. So they're saying which one has the same number of electrons? Let's see. So ammonium is NH4 plus, and it is formed when ammonia reacts with H plus, makes a dative bond. Yeah. So you have nitrogen right here with 3 hydrogens. These are normal covalent bonds. This is the lone pair of nitrogen, nitrogen, hydrogen, not nitrogen, hydrogen, nitrogen, hydrogen electron. This right here is your dative bond. Now, right here, let's see the electrons. Nitrogen has 7 total electrons, 2 inner and 5 outer. So you have 1, 2, 3, 4, 5. 5 and 2 are inner electrons. To total 7 electrons. And then you have 3 electrons of hydrogen, one of this, one of this, one of this. So a total of 10 electrons. And let's see, magnesium has 12, sodium has 11, neon has 10, this has 8. Answer therefore is C. Now what you usually the mistake that you make is you don't realize there's a dative bond with N and H. So there are no electrons of the H plus that is making a dative bond. This hydrogen has 0 electrons. Clear? All right, now you got to find the bond angles. We can do that by calculating the steric number. Let's see. So which is the increasing bond angle, smallest to largest? Let's see. So let's find this bond angle right here. Central atom is this carbon. How many sigma bonds around it? 1, 2, 3, and 4. So steric number would be 4 plus 0 lone pair. Steric number is 4. Hybridization is sp3. Bond angle will be 109.5. Then you have this right here. It has 1, 2, 3 sigma bonds. 3 sigma bonds, 0 lone pair, steric number 3, hybridization sp2, bond angle 120. Then you have this, which is the central atom. You have 2 sigma bonds, and oxygen has 6 outer electrons, so 2 lone pairs, steric number 4, hybridization sp3. 2 lone pairs will decrease the angle by 5, and it will be 104.5. So this is Z, this is Y, and this is X. So which is the smallest angle? Smallest is Z, then X, then Y. So Z, X, Y. The answer therefore is A. Clear? Question number 5. Let's see. The description of the bonding in 3 substances are given below. Substance 1. Strong covalent bonds, permanent dipole attractions between molecules. Let's see. Can A be permanent dipole attractions? In A, substance 1 will have hydrogen bonding. Yes, which is a type of permanent dipole, but there will be hydrogen bonded. Right? Al2Cl6. In Al2Cl6, the molecule is non-polar. If the molecule is non-polar, which type of forces will they have? Temporary dipole, induced dipole. Can't be B. CH2Cl2. So CH2Cl2 is something like this. Yes? This is a non-polar molecule, a polar molecule, and this has a permanent dipole. The dipole will go from C to Cl. So this has permanent dipole forces, yes. CH4 is non-polar. This will have temporary dipole forces. Clearly the answer is C. You don't even have to check the others. You see? All right. Which type of bonding is never found in elements? So which type of bonding will you never see in elements? Can you have covalent bonds in elements? Yes. In elements, I mean, for example, a Cl element with another Cl element, can you have covalent bonds? Yes. Can you have ionic bonds between elements? No, this will always be between a cation and an anion. So the answer therefore is B. Can you have metallic bonds between elements? Yes, between metals. For example, sodium metal with another sodium metal. Which type of bond will this be? Metallic. And can you have van der Waals forces between elements? Yes, you can also have van der Waals forces. So not this, not this, not this. Answer is B. Because for B, you need ions, not elements. Question number 7. Using the information, what is the enthalpy change Q for the reaction described? So they've given you this. They're asking you this enthalpy change. Now they've given you the enthalpy change of solution of CSBr. What do you mean by enthalpy change of solution? Enthalpy change of solution is where the solid becomes aqueous ions. So let me make this CS plus gaseous plus Br minus gaseous becoming CSBr solid. We need to find this. Now what is solution of CSBr? When the solid becomes aqueous. So when this becomes aqueous, we call this what? Enthalpy change of solution. What is the value for that? Plus 25.9. Now hydration of CS. What do you mean by hydration? Where gaseous ion becomes aqueous ion. So when this becomes aqueous ion, this is minus 276. And hydration of bromide, when this becomes this is minus 335. Now you figure out the start. What will be the start? Now you have 3 boxes. Box 1, box 2, box 3. Which will be the start? You have a tail here, and a tail here. Can we call this the start? You have a head here, head here, head here. Can we call this the end? So you can go from start to end directly, which will be equal from start to intermediate to end. That's what law of thermodynamics says. This is your intermediate, therefore. Yeah. Now, what are the values from start to end? It's this and this. So that's minus 276 plus minus 335, which is equal to start to intermediate, that is X. and intermediate to end, that is plus 25.9. Now let's calculate this value. Minus 276 plus minus 335 minus 25.9, and this comes out to be A, minus 636.9. The answer is therefore A. Clear? Question number 8. Which enthalpy change is indicated by X in the cycle? So what is X? Let's see. What is happening here? You have H2O2 and carbon right here, and this is, they're saying, formation of carbon dioxide. Do you see that? 1 mole of carbon dioxide being formed from carbon and oxygen elements in their constituent elements in their standard state. So yes, this is formation. You're also getting water. Do you see? You are getting water, but how many moles are we getting? We are getting 2 moles. Formation is always for 1 mole. So can we say you are also forming water? Yeah. So we are also formation. Can we call this formation of H2O? Yes. But this will be for how many moles? 2 moles. 4 times the enthalpy change of combustion of hydrogen? No. If anything, it should be formation of water. So right here you have formation of water. Yeah. And this will be what? It will be 2 times the formation of water. Now, let's see here. So we know that now you'll be like, Miss, why can't it be combustion of hydrogen? Why can't we call this combustion of hydrogen? Because combustion of hydrogen is the same thing as formation of water. But right here, it is not 4 times the combustion of hydrogen. It should be 2 times the combustion of hydrogen because you have 2 moles. Yes. So if you were to call this combustion, this would be combustion of 2 moles, not 4 moles. Can't be B again because 4 moles the combustion of hydrogen. It's not 4 moles. It is 2 moles. So then you know that it is what? Formation, for sure. Now, they're saying minus 2 times the enthalpy of formation of water. Now, it is not minus 2. It will be plus 2. Why? Because formation of water is exothermic itself. Yes? So if you do minus 2, so minus 2 times minus will give you a positive value. But you know that this formation should be exothermic. So if it is exothermic, then you should have plus 2 times a negative value. That will give you negative. And how do you know formation is exothermic? Because formation of water is the same thing as combustion of hydrogen. And we know combustion is exothermic. So this overall value should be a negative value. So if you multiply it with a negative, the negative with a negative will become positive. So that can't be the answer. The answer therefore is D. Clear? Understood? 9. Copper dissolves in dilute nitric acid, producing a blue solution of copper nitrate, water, and okay. So you have copper, which dissolves in nitric acid to produce copper nitrate, nitrogen 2 oxide. So what do you mean by nitrogen 2 oxide? Where the oxidation state of nitrogen is 2. Yes. So nitrogen 2 oxide, where nitrogen will be 2 plus, oxygen is 2 minus. So nitrogen 2 oxide will be what? NO. And as the only product, and water. Yeah. Now we need to balance it. How many moles of acid react with 3 moles of copper? So let me make this 3 moles of copper. Now you got to balance it. So let's see. You need to find these moles. So if you have 3 moles here, then you will have to put 3 here. Yes. Now when you put 3 here, so your nitrate ions become how much? Nitrate ions become what? 3 2s are 6. Yes. So, and now you also have nitrogen here. So how many, let's just balance the nitrogen first. So how many nitrogen will we have here? 2 3s are 6 and 1 7. So you have 2 here and 2 times 3. No. You have N2 here, right? Yeah. This is, can I write this as N2O6? Yeah. And then you're multiplying it by how many moles? 3 moles. So 3 twos are 6 and 1, 7. So you have 7 nitrogens there. So let's see. So how many moles of acid react with 3 moles of copper? So you have 7 nitrogens there. So you will put a 7 here. Now let's see, does it balance out? You have 7 hydrogen here. How many hydrogens do we have here? 2. So you will put 7 upon 2. That's 3.5. Yeah. So 3.5 oxygen, 4.5. And how many oxygens do we have here? 2 3s are 6. 6 times 3, 18. So how will we balance the oxygens then? So let's see now. Let's, in fact, rather than trying to balance it on your own, what you can do is you can just take the options and you can plug them in and see whether they check out or not. Yeah, which one checks out? So for example, right here you have 2 moles of acid. So if it is 2 moles, does this check out? You have how many hydrogen here? 2. And how many hydrogen over here? 2. So this is balanced. How many nitrogen here? 2. And how many nitrogen here? You'll have to put a 3 here, right? To balance the copper. So now how many nitrogen here? 2 times 3, 6 and 1, 7. But this does not balance out. You see, does not check out. So not 2. Let's put 4 here. When you put 4 here, you know you will have to put 3 here to make the coppers balanced. Let's check the nitrogen. You have 4 nitrogen here, and you have how many nitrogen here? So definitely it can't be 4 because just here we have 6. Can't be the answer. Clear? So can't be 4. 6. Let's make this 6. So if you have 6 nitrogen here, we have 6 nitrogen here and 1 nitrogen here. So even if you have 6, and even if I put a half here, the nitrogens will not balance out. It will be 6.5. You can't put a 0 here. You can't be like, oh, this is 0. You understand that? So it'll still be 6.5. Can't be the answer. And therefore, your answer would be 8. Clear? So just by looking at this, you can cancel out 2, 4, 6, and then you just make this 8. And now you have 8 nitrogens here, and then you have 6. So you put a 2 here, yeah, and then you can balance out the rest. So just based on the balancing of nitrogen, you figured out it can't be 2, 4, 6. Has to be 8. Now nitrogen reacts with hydrogen to produce ammonia. This right here is nitrogen reacting with hydrogen. So you have N2 plus 3H2 giving 2NH3. This is Kc. So you will have initial reacted at equilibrium. So let's see N2. They've told you the mixture of 2 moles of nitrogen, 6 moles of hydrogen. So you have 2 moles of nitrogen, 6 moles of hydrogen, and 2.4 moles of ammonia is allowed to reach equilibrium in a sealed vessel. So now they've given you the initial moles of ammonia also. So they've told you that they are allowed to reach equilibrium. They've given you initial of all. Yeah. Now, it is found that 2.3 moles of nitrogen were present at equilibrium. So how much? 2.32. So we have to find all of this. Now you see, the thing is, you have more at equilibrium than initial. Do you see? Nitrogen initial was 2 and at equilibrium you have 2.32. So that means you must have, maybe the reaction is going in the backward direction where you are making more of this. Yeah. So basically this would be how much? How can you have more? So you, this plus this will give you 2.32. So this becomes what? 0.32. Clear? Now the ratio of this and this is 1:3. So this will be what? 0.32 times 3. And that becomes how much? 0.32 times 3, that is 0.96. So this is 0.96. Yes? And this plus this will give you the value at equilibrium, which will be 6.96. So technically, this has become the product, and this is now the reactant. And how did we know that? Because we had more of this at equilibrium than initial. Now this is in the ratio of 1:2. So if this was 0.32, this will be 0.32 times 2. So 0.32 times 2 is 0.64. And you know this minus this will be the amount at equilibrium. So 2.4 minus 0.64, that is 1.76. Clear? Now, let's see what your answer is. So you have this. So it will be 1.76 squared upon, what is this? 2.32 times 6.96 cubed. Yes, that becomes your expression for Kc. And your answer therefore is A. Clear? Is this clear? All right. Question number 11. Nitric acid is produced by oxidizing ammonia. The first step to react ammonia with oxygen in the presence of a catalyst to form nitrogen monoxide. Which conditions will produce greatest yield of nitrogen monoxide? So you need greatest yield of this. So you need a higher yield of this. So they're saying how? Forward reaction is exo. Backward will be endo. Let's see. Increasing the temperature. Let's see, will that or will a lower temperature help? So you want to make more NO. So if you decrease the temperature, system will try to oppose it. It will try to increase it. It will try to favor the exothermic side. Equilibrium will go forward. So low temperature increases the yield because equilibrium goes forward. Let's see pressure. So for pressure, you have 9 moles here and you have 10 moles here. So can I say if I decrease the pressure, system will try to increase it. It will try to favor the side with more moles. Equilibrium will go forward. So low pressure and low temperature. Therefore, the answer is D. Clear? Low pressure and low temperature will favor the forward reaction. Question number 12. The height of the peak of the curve in a Boltzmann distribution represents the number of molecules that have the most probable energy. That is the highest energy, yes? You see this right here? This is the highest energy that you have, the most probable. I mean, you can't have an energy higher than this. This is called the most probable. A sample of gas has temperature decreased without changing number of moles. So you're decreasing the temperature. How will the curve shift? It will contract and increase in height because the number of moles need to stay the same. Yes, that's what happens when you decrease the temperature. What happens to the most probable energy? It shifts to the left and upwards. Yeah. Which statement describes the features of the curve when temperature decreases? The value of most probable energy would stay the same. Does it stay the same? No, it increases. Can't be the answer. The number of molecules with most probable energy would increase. Molecules with energy, will they increase or decrease? Let's see that. We'll see that. Let's see the other options. The area under the molecular energy would decrease. No, area under the curve would stay the same because number of molecules stay the same. The number of molecules at very high energy end of the distribution would stay the same. No, they will also decrease because you know very high energy, by that they mean the activation energy. So you know these molecules with activation energy have decreased. When you decrease the temperature, rate decreases. Why? Because the number of particles having activation energy have decreased. So this is also sorry, this would decrease, by the way. The value of most probable energy, this is the energy, right? So initially it was this, now it's become this. Yeah, energy is on the x-axis. So this is A is wrong, B is wrong, A is wrong, C is wrong, D is wrong. The answer therefore is B. Even though the statement's pretty vague, we can't really tell, we don't really know, but we know A is wrong, C is wrong, D is wrong. Ammonia exists as a simple covalent molecule. Ammonia can react with a suitable reagent to produce ammonium ions. So ammonia is a base. Yes, it must react with an acid which will donate a proton or lose protons, and then it will gain that and become ammonium. Yes. So let's see. Ammonia can also react with suitable reagent to form amide ions. So how can it form amide ions? By NH2 minus. Let's see which of these nitrogen containing species are present in the aqueous solution of ammonia. So aqueous solution of ammonia means ammonia with water. Yeah, you know ammonia is a base. You know water has H plus and OH minus. So this will lose the H plus, and with this it will make ammonium ion. Yes, so you will make ammonium ion and you will have OH minus ion left behind. Yeah, so definitely you are making ammonium ion. And what else they are saying? Which of these nitrogen containing species are present in an aqueous solution of ammonia? In aqueous solution of ammonia, you will also have aqueous ammonia, because ammonia makes hydrogen bonds with water. So you will have ammonia and ammonium both. The answer therefore is B. Some of them will make dative bonds with the H plus and make ammonium. The rest of it will make hydrogen bonds with water. Yeah. Which problem can result if too much ammonium nitrate is applied to crop by farmers? So you know you have, if you apply too much on crops, they are on soil. When it rains, the water will take this nitrogen content and leach it into the nearby rivers and lakes. Yes, and it will result in eutrophication. Let's see. So they're saying not all ammonium nitrate is used by plants and makes the soil alkaline. Not alkaline, because ammonium is a conjugate acid. So if anything, ammonium will not make the crops alkaline, it will make it acidic. Can't be the answer. Rain washes some of the ammonium into the river where it forms a precipitate. It can't form a precipitate. Ammonium nitrate is, all nitrates are soluble. So nitrates will not form precipitates. Some of the ammonium nitrate dissolves in groundwater, which may be used for drinking. Okay. Ammonia is produced. This lowers the pH of the soil. So if ammonium nitrate remains in the soil, can ammonia be produced? Not unless you react it with a base. Only if reacted with a base will it produce ammonia. Otherwise, it can't produce ammonia. Clear? I mean, if ammonium ions react with a base, then only, let's say they react with any base. Then only, because this is a conjugate acid, this is a base, the conjugate acid will lose a proton, become ammonia, and the base will become H2O. Yes? So only if it reacts with the base will it make ammonia, otherwise it won't make ammonia. So D is also wrong. The answer therefore is C. Even though we haven't directly really studied about ammonium nitrate going in groundwater being used for drinking, but we studied the rest of it. And we know that is not true. And you need to know your theory clearly. Because if you think, oh yeah, okay, it will make the soil alkaline. No, it can't. Because ammonium is conjugate acid. It will not make it alkaline. B is wrong, because it will not form precipitate. Ammonium nitrates are soluble. All nitrates are soluble. D is wrong. It will not lower the pH of soil by producing ammonia unless it has reacted with a base. Answer therefore is C. Even though we don't know it directly, but we know the rest of it. So you work your way through elimination. When descending group 17 from chlorine to iodide, which statement is correct? So you're going from chlorine to bromine to iodine. Hydrides become less thermally stable. What do you mean by hydrides? Halides, yes? Hydrogen chloride, hydrogen bromide, hydrogen iodide. You know the bond length increases, so they become less stable. They can break easily. Hydrides become less thermally stable. And why do they become less thermally stable? Because the bond length increases, not because they're weaker reducing agents. That has nothing to do with bond length. Yeah, option A, this part is correct, but the reasoning is wrong. Yeah. Now, the hydrides become more thermally stable. No. The volatility of the elements decreases. So let's see the volatility. Volatility was inversely proportional to the strength of van der Waals forces. If van der Waals force increases, volatility decreases. And you know, down the group, the van der Waals forces increase. Why? Because number of electrons increase. So can we say volatility will decrease? Yes. Volatility increases? No. What is volatility? Ability to escape as vapor. And they can't easily escape as vapor because their intermolecular forces become stronger down the group. 16. A powder is known to be either single sodium halide or a mixture of two sodium halides. A sample of the powder was dissolved in water. Okay. So now they're saying it could be either a single halide or two halides, two halogens or one. So let's see. Silver nitrate is added. A pale yellow precipitate was formed. So what is this pale yellow precipitate? AgI. That means sodium must have NaI. Yeah. When concentrated ammonia was then added, precipitate partly dissolved, leaving a darker yellow precipitate. So now the precipitate is dissolving. And if the precipitate was only AgI, would it dissolve in ammonia? No, because AgI is insoluble. So that means there is something else. Yeah. So they're saying that when you are adding concentrated aqueous ammonia, precipitate is dissolving partly. So partly which one dissolves in concentrated ammonia? So in concentrated ammonia, which of the two will dissolve? AgBr or AgCl? Do you remember one dissolved in dilute and one dissolved in concentrated? AgCl. AgCl will dissolve partly in aqueous ammonia. In concentrated aqueous ammonia, AgCl will dissolve because you had two precipitates. You had an AgI and you had an AgCl. So they're saying partly dissolves. So which one is dissolving partly? The one with chloride, AgCl. And the one which stays is the iodide. The answer therefore is D. Clear? If they would have said dilute aqueous ammonia, then it would have been AgBr and AgI. Clear? Which statement is correct? Doctors can use the very insoluble magnesium sulfate to investigate the digestive system. Now, you know, magnesium sulfate is not insoluble. As we go down the group, the solubility of the sulfates decreases. So magnesium sulfate is soluble, barium sulfate is insoluble. Yes? So not true. Because magnesium sulfate is not insoluble. Yeah. Farmers can lower the pH of soil by spreading calcium carbonate on it. Can calcium carbonate give you a lower pH? Lower pH means that you need to make it acidic. Is this acidic? No. Is it releasing any H+? No. So how can you do that? Students can test solution of sulfate by using barium nitrate followed by HNO3. Yes. Why? Because barium nitrate is soluble. So barium nitrate will give you barium ions, nitrate ions. Once you have barium ions and nitrate ions, to that, if we add sulfate, so barium sulfate or a white precipitate is formed. Yes, so that is true. Then they are saying insoluble hydroxide, barium hydroxide. No, barium hydroxide is soluble. It's a clear solution. So this is wrong. You don't even have to read ahead, you know. So this is soluble. This is acidic. Can't be. The answer therefore is C. So you see, these things you haven't done directly really. I mean, option C here, you probably do remember from O levels. But even if you don't, you see the others are not true. And you know, nitrates are soluble. So this will give you barium ion, nitrate ion. Then when you add sulfate, that will give you barium sulfate, which will be a white precipitate. Clear? 18. Solid X was placed in excess of liquid Y. Okay. A colorless. So X needs to be solid. So, all right, these are all solids. In liquid Y, a colorless gas was given off. So to barium carbonate, when you add that to water, they are saying a colorless gas is given off. So barium carbonate will not react with water because barium carbonate is insoluble. All carbonates are insoluble. So when you add it to water, nothing happens. Stays the same. Colorless gas given off, can't happen. Calcium to sulfuric acid. So when you add metal to acid, what will you get? Salt and hydrogen gas. Metal and acid gives salt and hydrogen gas. Metal and acid again gives salt and hydrogen gas. They are saying colorless gas is given off. Yes, yes. White precipitate was seen. Is magnesium sulfate white precipitate? No, it is not. Is calcium sulfate white precipitate? Yes, because as you go down the group, the sulfates, their solubility decreases and they become precipitates. So this is a precipitate, this is aqueous. Strontium carbonate with hydrochloric acid. What will this give you? This will give you carbon dioxide. So this will give you strontium chloride plus water plus carbon dioxide. Yeah, strontium chloride is not a precipitate. All chlorides are soluble except silver, lead. These chlorides are insoluble. This is soluble. Can't be the answer. Answer therefore is B. Clear? Two oxides of period 3 elements are added separately to water. Let me put all the elements: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Not bothering with argon, all right? Now they're saying you add these to water. Both react with water to form colorless solution. So when you add sodium to water, what will you get? Sodium with water will give you what? What? NaOH. Magnesium will give you what? Magnesium hydroxide. Now they're saying both react to form colorless solutions. One solution is alkaline and the other solution is acidic. So let's see. What could be the two oxides? So they're saying two oxides. So you're adding oxides to water, my bad. So you're adding the oxides to water. So what will be the oxide of this? Na2O. What will be the oxide of this? What will be of this? What will be of this? What will be of this? And what will be of this? SO2. Now they're saying you're adding these to water and they will react. Now sodium oxide and magnesium oxide, they dissolve. These are the ones which will react. Yes. In this also, aluminum and silicon does not. Why? Because these are giant macromolecules. So these do not react with water. Clear? So we know that these guys dissolve. We can probably consider this. It could be this and this. Can't be Al2O3, can't be SiO2 because those don't react with water. Now, both react to form colorless solution. All right. So if you add this to water, what will you get? Oxide will become hydroxide. This will also become magnesium hydroxide. These guys don't react. This will become what? P4O10 with water will give you what? P4O10 with water will give you what? H3PO4. And this will give you what? H2SO3, sulfurous acid. Yes. Now they are saying they both react to form colorless solution. One solution is alkaline, the other is acidic. So which ones will be alkaline? Alkaline would be these. Which ones would be acidic? These. Now let's see. They are saying they dissolve to give colorless solution. Now, is magnesium hydroxide a solution? No, it is a precipitate. So will it give you a colorless solution? It will give you a white precipitate. Can it be magnesium hydroxide? No. One is definitely sodium oxide. Yeah, because this will be a solution. This will dissolve. So one is definitely Na2O. Because it's ionic, it is alkaline, and it will dissolve also. Can't be magnesium hydroxide because it will not dissolve to give you a colorless solution. It will be a white precipitate. The other, they are saying, will be acidic. So these two are acidic. Yeah. Let's see our option. We know one is definitely sodium oxide. Can't be this. Can't be this. One is definitely sodium oxide. Can it be SiO2? No, we've already eliminated that. It can't react with water. Giant macromolecular. Therefore, the answer is C. Clear? Let's see question number 20. Which compound shows stereoisomerism? So stereo is cis trans and chiral. So 2-methyl-butene. So 2-methyl-butene. Does it have a chiral center? No. Does it have any cis trans? No, because you have a CH3 here, CH3 here. Can it show stereoisomerism? No. 2-chloropropane-1-ol. So 2-chloropropane-1-ol. No cis trans. Let's check for chiral. Can this be chiral? No. Because 2 H's. Can this be chiral? Yes. The answer therefore is B. You don't even have to check the rest. Do you understand this? If you want, I can just do it. Difluorochlorobromomethane. So methane, 1 carbon. Difluoro. So 2 F's. Chloro, bromo. Can it show chiral? Can it be chiral? No. Pent-1-ene. Pent-1-ene. Can it show chiral carbon? No. Can it show cis trans? No. The answer therefore is B. Clear? Is this clear?